Dear student, we'll continue class 9, ICSE class 9, Logarithm, chapter 8, question number 6. In question number 6, it is given state true or false. In Roman 1, in question number 6, Roman 1, it is given if log x base 10 equal a, then 10 to the power x equal a. So we have to find whether it is true or false. So it is given, it is clearly log x at the base 10 equal to a. It means that 10 to the power a equal x, but it is given 10 to the power x equal to a. So it is false. So the first statement is false. So we can write it. It is false. In number 2, it is given if x equal to y, x to the power y equal z, then y equal log x base z. Now we'll check. It is given x to the power, in power it is y equal to z. So we can write it actually as it is log z at base x equal to y. It should be, or y equal to log z base x, but it is given y equal to log x base z. So that one also false. The second statement is also false. In statement 3, it is given log 8 at base 2 equal 3 and log 2 base 8 equal 1 by 3. So 1 by 1 we'll check. The first one, it is given log 8 at base 2 equal to 3. It means 2 to the power 3 equal to 8. So that is true. In the second one, it is given log 2 at base 8 equal to 1 by 3. It means 8 to the power 1 by 3 equal 2. And that one also correct, as 8 equal to 2 cube and power is 1 by 3. So power multiplied, 3 cancel, so equal to 2. So the third statement is true. We'll write here true. So this is question number 6. Now we'll start question number 7. Question number 7 is find x, find the value of x if number 1, Roman 1, log x at base 3 equal 0. So this is the first equation. From this equation we'll find the value of x. So we'll solve it for x. Here it is given log x at base 3 equal to, in place of 0, we can write, we know that log x base x, if base and the value of log is same, then it is 1. Then another example I am giving, suppose if we write x to the power 0 equal to, what is the value of x to the power 0? We know that anything to the power 0 is 1, and if we write it in the logarithmic form, then we can write it log 1 at base x equal to 0. It means log 1 at base anything, the value is 0. So we'll write here log 1 base 3. Why base 3? Because here also base 3. This implies, now both sides is log, we can remove the log as the base is same, so we can write x equal to 1. So this is the value of x in Roman 1. Now in Roman 2, what it is given? In Roman 2 it is given log 2 base x. It is given log 2 base x equal minus 1. So we can write it, we can solve it in this way, equal to log 2 base x equal minus, as it is minus, we can write it minus log 1, as I said that if the base and the log is same, then the value is 1. So as it is base x, so we can write it log x base x. So log x base x equal to 1, sign is minus, so minus is there. This implies, so log we can remove, so there will be 2, we can write 2 equal to minus x. This implies x equal to minus 2. So this is the value of x. In question number, in Roman 3, now we'll solve Roman 3. In Roman 3, it is given log 243 at base 9 equal x. So in the similar way, if we do, so we can write log 243 base 9 equal. So x, we can represent x into 1. So we can write x into log x base x. This implies we can write log 9 it should be, as base is 9, so we have to write 9 here. So if it is 9, then here also 9 equal x log 9 base 9. So we can write it log 9 to the power x at base 9 according to the law. This implies, now log we can remove from the both side. So we can write 9 to the power x equal to, we can write 9 to the power x equal 243. This implies 3 to the power, as 9 is 3 square, so you can write 3 to the power 2x equal. In case of 243, If we factorize, so it is so 1, 2, 3, 4, 5. It means c to the power 5. So in place of 243, we can write to the power 5. Now in both sides base is equal, so we can compare power. So it is 2x equal 5. This implies x equal 5 by 2. So this is the value of x. Now we'll solve Roman 4. In Roman 4, it is given log x minus 7 base 5. Log x minus 7 at base 5 equal to 1. So I hope you can do it, because in the similar way we have done already 3. We can write it log x minus 7 at base 5 equal. In place of 1, we can write, what we'll write? We'll write log 5 base 5. Why log 5 base 5? Because here also the base is 5. That's why we'll write log 5 base 5. This implies, one thing you have to remember, unless the base is same, we cannot remove log. That's why here the base also 5, here also 5. Now we can remove log, so we can write x minus 7 equal 5. This implies x equal to 12. So this is the value of x in question number 4. Now we'll solve Roman 5. In Roman 5 it is given log 32 at base 4 equal x minus 4. So this is little bit different. So we'll solve it in this way. Log 32 at base 4. Then this 4 will bring it in the left hand side. So it will be plus 4 equal x. This implies log 32 we can write 2 to the power 5 plus, therefore we can write 4 log 4 base 4, because here base is 4, equal, we can write x log 4 base 4. This implies, now we can write it as the power is 5, we can write it log 2 to the power 5 plus, here we can write it log 4 to the power 4 at base 4 equal, here it will be in the power, so we can write it log 4 to the power x at base 4. Now we can see here log, here also base 4, here also base 4, here also base 4. Now as it is plus, so we can write it log 2 to the power 5 into, here we can write 4 to the power 4, we can write 2 to the power 8 equal, at base 4 equal, we can write log 4 to the power x at base 4, or we can write here 2 to the power 2x. This implies, now we can remove log from both sides, so here will be 2 to the power 5 plus 8 equal to 13 equal, here we can write 2 to the power 2x. This implies 2x equal 13. So x equal to 13 by 2. So this is the answer, x equal to 13 by 2. So this is little bit longer. Carefully you have to check all the steps. Now the last one in question number 7, Roman 6. We'll solve Roman 6. In Roman 6 it is given log 2 into 2x square minus 1 at base 7 equal 2. So this is as usual, we'll take log in both sides. Here it is 2x square minus 1. In place of 2 we can write 2 log 7 base 7. Here 7 because here also the base is 7. Now we can write log 2x square minus 1 at base 7 equal log 7 square at base 7. This implies 2x square minus 1 equal 7 square equal to 49. We remove the log from both sides. This implies 2x square equal, here will be 50. This implies x square equal to 25. This implies x equal to 5. So this is the value. We can use plus minus 5. So this is the value of x in question number 6. So this is just we solved question number 7. So in the next video we'll start from question number 8.